Okay. Thank you, everyone. Thank you for the panelists. I'm really excited for the upcoming discussion. The topic is AI and crypto, more broadly speaking. Again, so a bit of an update to this slide. Let's start with a quick round of, just introduction. Try to do it from the lens of AI, in the sense of how your project may or may not interface with AI. Let's start with Guy.
Hey everyone, I'm Guy Zyskind. I'm the founder of Phenix. We're building an FHE fully homomorphic encryption coprocessor. Also, part-time, I'm personally dabbling with things related to AI and privacy. So wrote a few papers on private information retrieval in the context of large language models and how to do LLMs, inference, secure inference inside of trusted hardware.
Yeah, hi, I'm Junda from Brevis. Yeah, our interface with AI is actually our first official, public mainnet launch is with Trust Labs. Their ZK what they call media score, leveraging our underlying, infrastructure and proving systems, so the user can throw in whatever his, past activities, storage, ERC20 balance, whatever, and then get, feel like a social score, in the US is like a number, a magical number, and then they can take that number to kind of claim different rewards and get different, VIP status tiers.
I'm Roshan from Marlin, and our interface with AI is primarily on the infrastructure side. So since we run a proof market, the way we approach it is what sort of infrastructure techniques and optimization that you can do to bring ZKML to reality today.
Yeah, thank you. So we have time, and I want to start with some basics, right? So I'm not sure if everyone here is on the same page, even with what is AI, or I would actually tackle this question from what are the problems we see with modern ML AI systems today. If anyone of you wants to start, describe a bit about current status and issues that we have with AI systems.
So yeah, I can start. I think the number one issue is, everyone has their own definition, right? So just like cloud computing a few years back, everything can be claimed as AI. Even traditionally, more falls into the statistics, right? So now it's hey, let's use the new, sexier branding, and suddenly everything is AI. I would kind of more the old school prefer the machine learning term. It basically said there is a training process, you throw data, and you get some model, whatever there is, for the lack of better term, and now you do inference, right? So that to me is more the typical classical definition of the whole thing. But of course, nowadays, every single company try to be a little bit AI related, so now the term is kind of heavily, I don't really see some companies claiming they are doing something AI, but I don't really see the part of the machine in there. Yeah.
Okay, abuse of the term. That's a good point. How about stuff with security, with privacy of AI? Anyone wants to chip in?
I'll jump in. I think there are really two major properties we're interested in, right? One of them is, let's say the ZKML branch, which is basically verifiable AI. So you want to know that actually when you have an AI provider, right? Something like ChatGPT or whatnot, when you give them a query, that they actually run the model correctly, they do the inference correctly, and they give you the right result. This could be out of pure maliciousness, but actually there's a recent paper I'm familiar with, which actually just said something much simpler, right? These companies like OpenAI and that, they spend a lot of money. They actually subsidize people's queries right now because it's so expensive and the compute is so expensive. So what if theoretically, like they don't tell you, and you know, in some cases they would switch your query to like a like GPT-3 instead of 4, or they quantize the model or use some kind of tricks that you're not aware of, and they will give you like worse results. And as a user, you would not know the difference. So that's where verifiability is very important. And I think the other one, which is, I think, I mean, I'm biased, that's what I'm looking at, but I think is often overlooked is confidentiality and privacy, right? Like, when I'm not comfortable, and literally, actually, there's like already some, big companies, I think like Samsung and others are actually telling their employees, like, don't use like, ChatGPT and stuff like that, because you might be leaking IP or some sensitive information within your queries. So that, to me, is like the other security property that is very important.
Cool. You want to add something, Roshan?
Yeah, so, yeah, I would agree with what Omer said. In terms of, we kind of had a split in terms of like ML and AI, a lot of it used to be just done locally on like the user's devices to basically like enhance existing application and all that. And there has slowly been a shift in the Web2 world towards like, big models, big amount of data training and all of that, which you can't really do on user's device. And you essentially end up centralizing all of that like power into like a few centralized providers, right? And hopefully we get to reverse that trend in like the ZK space.
Right. So I want to, after we talked a bit about problems with AI, I want to maybe look at it from the positive side of it. And we all have some work in Web3. And how about, I mean, you touched it, Junda, before about scoring. Can you maybe share more, one of you, about applications of AI in the Web3 space? Some that might be more immediate one, short term, and some if we can kind of like even imagine or think more long term, where AI can find like a good fit into the space.
Right. Yeah, I think our launch last month, the case with Trust Labs, it's kind of the best we can do today, right? So limited by all the available hardware resources and all the basically what's available today, and that's the best we can do. There's a pretty minimal ML component, but then the ZK make it like, in the best case, still 1 million times harder. So that's why all the underlying resource requirement will still be pretty significant, right? And also associated with the proving cost and also in the end the on-chain verification. That's today. But for the future, which is my favorite topic, is I don't even see Web3 is only for humans. Basically I see as the machine intelligence keep moving forward, the best we can hope for is there will be a long time human and machine intelligence coexist. And that's the time Web3 really shine, because if you want to have a connection or a bridge between the two different kinds of intelligence, you have to reduce to the bare minimum that both sides can agree on, which is, I was a little bit biased, but which is just the math and the code. That's exactly what Web3 is doing. So I think that's kind of the grandest narratives for Web3 plus AI is down the road, it's not just for human itself, it's for between human and machine intelligence. And so that's we can have a common ground to keep the trust and keep the communication going.
Man, I love this angle.
It's a little bit science fiction,
yeah.
yes.
Didn't see this answer.
That's why my favorite topic.
Yeah, good to have you here.
Can I jump in?
Yeah, sure.
No, I want to talk about more applications that I think for AI in Web3 today. So I think two of them relate to like risk models. So one of them is DeFi, lending, all of that. Today it's like people, rightfully so, are pseudonymous, and so everyone kind of have to over collateralize when they get a loan, where they put stuff in DeFi. And maybe we can be a bit more efficient, a bit more capital efficient, and do something like an under-collateralized loaning, based on people's credit scores. But then there's a huge AI component and privacy component. So what if people can sign like through all of like their wallets, provide that like maybe encrypted, then have some model that is trained to actually compute a credit score, but it doesn't actually see people's like wallets and transactions in the clear. It does so over the encrypted data, and then the only thing that it spits like on-chain is like some final credit score, and then on-chain, you also need verifiability here, of course, but then on-chain, like, you can kind of assess the risk of that user without actually knowing who they are or to link them, and then give them perhaps like, better terms for the loans. There's another variant of this that is more global that doesn't actually require privacy. So, if I'm like Aave, then, I can actually run like a lot of models that are just crunching a bunch of like on-chain data, building like our own risk models, then again spitting them out on-chain to our contracts, and then kind of like tuning different parameters, but again, in verifiable ways, so like Aave's users can trust them, because that probably is too heavy and too expensive to happen off-chain. And then I think the other one, which is completely separate from risk or DeFi specifically, is something like discovery or recommendation in the blockchain space. So as I'm sure you know, if you're in the space, there's like a proliferation of like L1s, L2s, L3s, apps. Like you really can't keep up with the noise. And there's no real like good, like there's no search engine for like, blockchain applications, blockchain things that are happening. So what if there's like an actual recommendation engine that kind of crunches these, checks these, have some like objective verifiable metrics that they can actually show users the results, and the caveat here might be also privacy, like, different users may have different preferences, but they wouldn't want to reveal that on-chain. So that's like another angle that I think is interesting.
Oh, super nice, interesting examples. You have more?
So the way I tend to look at like a significant portion of Web3 is it's basically Web2 with way better foundations, right? So in that sense, a lot of like use cases of AI that you see in the Web2 world essentially carry over almost like one-to-one to Web3 as well. Like so, I believe we mentioned like DeFi a lot, like in under-collateralized lending, the concept of a credit score and stuff like that. On the other side, you also have like recommendation in platforms like search engines. Social media is a big use case. We have Lens on the scene and all that. So yeah, I think quite a lot of like these types of use cases which seek to like emulate Web2 with better foundations, you can sort of just like transplant AI one-to-one from the traditional world.
Yeah, I actually want to kind of like follow up on what you said, or try to put it in some framework. Like what we discussed here, we mentioned some issues with AI systems today. And then the question was more into, so Web3, right, can benefit from AI same way as any other, let's say, industry can benefit from AI. And you're probably familiar with this like narrative that AI and crypto are opposing forces. One is like more pushing towards centralization, while one is more into removing trust and decentralization. So I think it's even, I want to touch on this point, right? And I think it's a bit broader, and it's good that we have like Guy here, because it's about this, how cryptography can actually interface with AI to generate some good, to help this kind of like AI systems. So one thing I wanted to ask you is about the narrative in general. Do we buy into this narrative? Do you think that AI will interface with crypto, as in cryptography, right? In the future, would the world see value in that? And then in what sense? Kind of like how much of these two different forces are going to get diffused together?
So, okay, let's probably start here. So, the almost like the one real innovation of the Web3 space is this concept of like programmable value, right? That's something that like programs didn't really have access to in the traditional world, and that's something unique that we have, right? And what that sort of means is that it's like a pretty democratizing force in terms of what you can do with AI. You no longer need one single centralized provider who controls value, who probably also controls the ML and AI that's running alongside it and all of that. You can really have like a pretty democratized like network of people running their own agents, which manage their own value and like sort of interact with each other in like a fully autonomous manner, right?
Yeah, I would say, in this crypto space, we also talk a lot about the incentive aligned, or at least incentive compatible, right? I think, many of the, so I try to avoid the things like we imagine a problem first, and then we work on a solution for an imagined problem, right? I think that seemed to be quite often didn't lead to anywhere. So I think with the, at least with the concrete example we launched with Trusta Labs is they have this very specific needs. They need to understand the user better. Then they do have a kind of previously purely implemented in Web2 technology, right? Runs on their own database, basically a traditional SQL database, and also a proprietary code that literally query the same RPC endpoint and does some calculation and spit out a credit score. Let's just, for simplicity, call it credit score. And of course, taking this credit score purely off-chain, already you can do different things. But what's missing is the final on-chain action part. So I think that's why for coprocessors, different coprocessor projects, the trust-free part is critical, because if you already has some additional trust, like be it some Dune or Graph or whatever, or your own database, you don't need to go this route. It's at least 100 times more expensive. You have to understand who is paying for this additional cost, right? As long as you can find, otherwise, it's not economically sustainable, right? Because even today with all these advancements in hardware, in algorithm, and generating ZK proof is still expensive compared to, like, I run my own SQL database, how expensive a query can be. So I think that's kind of changed the economic aspect completely. Every single proof has associated cost. So we need to make sure the benefit, or whoever is benefit from the proof, is willing to pay and at least cover the cost. I think that kind of, back to the AI specifically, why I think Trusta Labs case makes sense is their users knowing that by obtaining, after they obtain this proof, they got this score, they can easily go claim much higher value than what they pay for the cost. So I think that kind of makes the whole system running kind of by itself. I think that people, I would say, talk about the exciting use case more than looking at from the angle of who is paying for the cost.
I think it's an excellent point. I want to actually double down on it before I let Guy jump in, because I want to give an example to the same thing from FAG. Right? With full homomorphic encryption, you don't need to add like a proof. It's not an additional computation. It's a replacement, right? You do the AI encrypted. Yeah. So basically need to convince someone that they should move into a different type of a system, completely different system. So when we look at FAG, for example, you have one idea is to have confidential AI by way of encrypting and then like running over the encrypted, running the computation over encryption. The other way is to use like a TE, trusted execution environment. And this allows you, like NVIDIA, for example, they have this kind of like technology already, which allows you to have very little overhead. However, there is some kind of like trade-off, right? So you do pay in the sense that you need to trust someone when you do this like TE. And that's kind of like the heart of my question. I mean, we believe that we can convince of that? I mean, again, the narrative is I think is there for, in my example, data is not something you want to expose. You want to keep it confidential. Question is if people are gonna eventually agree to pay this extra cost to actually get the benefit of having like truly whatever it is, like trustless, fully confidential, better security. I don't know, Guy, you want to say something?
Yeah, I mean, I think this is a great point. First of all, I don't know. It really depends on the cost margin, right? I think there's going to be tiers. I think there's going to be valid use cases where you don't need privacy at all. I think there's going to be use cases where you need confidentiality to an extent, but it's not that sensitive. So maybe, and it's a lot of data. So maybe T's are going to be the T's are going to be the winning solution. today, if you asked me 2 years ago, I would probably have given, 3 years ago, probably given a different answer. But I do think that both FHE and ZK, like these deep cryptographic solutions, this is like an acceleration event. So definitely with hardware acceleration, again, it's not tomorrow, but I think within a few years, we're gonna see, the trend right now, in my opinion, is that cryptography is barely keeping up. The speed advancements in cryptography, deep cryptography, is barely keeping up with the demands of AI in terms of data and compute and all that. And I do think that, in the next few years, especially with what's happening in the industry, we're gonna see that trend shift where the advancements in cryptography is gonna overtake, and lowering the cost in cryptography is gonna overtake the demand increase in AI. And so it's much more likely that using FHE at scale, using ZKML at scale would become much, much more useful. But I do think it's always going to be, or at least in the next decade, it's going to be some spectrum. Some use cases, you're going to have to give up a little bit of in security, whether it's in privacy or verifiability. And in some cases, data is very sensitive. It's actually much more important than running the latest model and so forth, such that you would be willing to pay the extra cost.
Yeah, I think it's a perfect answer. I just want to say one thing, and then, if you guys want to add on top or just refer to what I'm about to say, because I think that point being made here is that there's some investment that we need to do, right? And there's going to be some kind of tiered-based solutions, but let's try to break it down into technologies. So what would you advise for people that are building towards this future? Which technologies to invest, either as builders, as investors? What tools do we see you think are going to proliferate in this kind of environment?
The question about giving advice to other projects?
I think that's the mental model.
Co-processor is my advice.
I'll give you an example, right? So just top of my mind, we see a lot of now this decentralized GPU clusters, which it makes sense. It's I would say quite a low-hanging fruit and solves perhaps a real pain. But when you try to think deeply about it, there are some issues or some technologies that needs to happen. You need, for example, verifiability, where before that you did not need it, right? Just assume you trust whatever provider. So this is kind of the what I'm trying to get at. What are the technologies? What are the tools? Where do you see people? Where do you think people should invest their time, resources?
Yeah, I will give my obviously biased answer to help driving our costs down, right? So I would like to see more proof aggregation, right? Basically the whole end-to-end pipeline. We can see obviously the proving hardware cost associated with the scale of the data, of course, is number one. And also the latency, how soon or how fast the user want to get the proof, right? That's number one. And then the number two is the final on-chain verification. It's another, I would say, kind of a hurdle, right? It's always there. We try to do everything we can, but Ethereum and whatever has the gas cost, has the curve they support. That's kind of not something can be changed really soon. So I'm personally very happy to see there are more projects coming up to say, hey, we can help you with proof aggregation. We can help you with even generating the proof itself in a more distributed way, so that we can offload kind of this part of the operation headache and also cost, right? And on the other side, that helps with the entire ecosystem, because I would say it's more like a supply chain, right? At every step, for co-processor, you have different projects try to choose a different priority and show their strengths, right, or advantages in there. And for, say, distributed GPUs, I agree there are some concrete technical issues, especially about the network bandwidth. We find it's a little bit hard to deal with, especially in the setup phase. But I'm very optimistic. People will come out, smart people will join, coming and see the challenge and the problem, try to find a solution. Right? I think that's kind of the healthy ecosystem evolvement I would like to see. Yeah.
I think I'll probably add to what Guy mentioned a while back in the sense that the AI ML space is a little unique in the sense that requirements keep going up with time, right? So, like what I need from a transaction hasn't really changed in like 10 years, right? I just need a sender, I need a receiver, I need an amount, and that's it, right? So, given like static requirements and as technology progresses over time, we've obviously seen ZK sort of like take over the space almost entirely, right? The issue with AIML is that you have your requirements basically going up. Any sort of performance that you can squeeze from your hardware just goes into making bigger and better models and stuff like that, right? So you kind of find yourself facing two options. Do I go for the latest and greatest in terms of AI and just basically have to swallow some trust assumptions in the meantime? Or do I stick to like cryptographic security, but hey, maybe I'm a few years behind the curve on like what's possible, right?
Honestly, I think we're kind of thinking about this the wrong way. I think, if you're in Web3, you want to build something on AI, then my question would be is like, what's the use case? What kind of data do you need? Like, what are you going to use this for? And if you don't know the answer, then my answer would probably be that you're just trying to ride the narrative cycle, then just like launch an AI meme coin. But if not, if you actually have a use case, if you actually have a need, if you actually have a demand, then okay, explain what it is. Explain what kind of models do you need to run, what kind of accuracy, what kind of users you're trying to attract, what kind of latency do you need, and then you can understand the trade-offs between the different technologies and say, okay, like, you know what, maybe I don't need, maybe it's fine that I somehow just like outsource most of my users' queries to ChatGPT with an API, but there's some sensitive database and user data that I need to search first, and that is a very, very simple, like, k-means or k-nearest neighbors, model, and that can be done with FHE today, but if and with ZK and as well, or if your comment is like, I actually need to run like 100 billion parameters model locally today, and I need to prove correctness, and for some reason my clients, users will not settle for less, then the answer is, okay, maybe wait for 3 years and become a design partner, for any one of us, and we can work together. Or if you need to ship in 3 months, then just use like NVIDIA's TEs or optimistic approach, and that should be good enough to start. So it really depends what are your demands. And to me, like, the technology and the assumptions and the trade-offs comes after that.
Great. I have to say that I'm enjoying every second of this panel. You guys are super talented. And therefore, I also want to open it up in a second to questions from the audience. Before that, I do want to ask one last question. So I guess same way as I'm enjoying, maybe Jensen, CEO of NVIDIA, and Sam Altman, CEO of OpenAI, is watching as well. They're enjoying, so they reach out. Let's say Jensen reach out to you, Roshan, and says, you will probably do a better job than I do. Here, you're now a CEO of NVIDIA. What are you going to do? What's the plan? Or Junda, right? You're now we're going to replace Sam Altman at OpenAI. What do you do? How do you fix the world? Fix AI?
So, my pipe dream, at least when it comes to the ZK space, is like a ZK native GPU, like of the sort of like what Fabric is working with, where instead of like GPUs working on numbers and stuff like that, they just work natively with like ZK fields and curves and all that. Right? And that would be sort of my top priority there.
So you say now, as the CEO of NVIDIA, you basically tell the guys, team, now you're going to move and be like ZK.
Forget about numbers. All we know is fields now.
Yeah, nice.
So my question is, maybe slow down a little bit. Slow down a little bit of the AI progress, right? I think the society, the technology might be there, but the society is not ready. I keep remembering I was the first to purchase, not purchase, but I I got the Google Glass. It's pretty cutting edge, but the society is not ready. I think that conflict, you kind of do not want you to be in the position say, hey, you truly believe in, say, AGI or whatever that can bring the eternal peace to human, period. But before that happens, the resistance or disagreement from the society might be a bigger issue to handle.
Yes. Guy, getting the reins of Google, anything you want to do to
Wait,
change?
is the question if I'm being
Yeah,
replaced?
now you're running Google.
Okay.
What do you do?
I do two things. I immediately find someone more qualified because there's no way I'm going to help AI, but I am appointing myself on some decentralized AI division because I think that's where I can add value and I'm interested in.
Good. Yeah, let's open up if anyone wants to ask questions from the audience. I see there's one over there.
Thank you so much. It was very interesting to listen to the panel, and I will ask probably the questions that we were not ready for. So here we talk about cryptography and machine learning, and we very much enjoy cryptography. We saw how it can do magic with ZK VMs, and we think it can do the same magic for something like machine learning, and also Fishy. But I feel like we're missing a big part of it is that the actual AI systems are still not secure. And whatever you're actually proving, so you can do ZKML, but whatever you're actually proving is a black box that even top researchers in machine learning don't really know how it works. So why shouldn't we dedicate more resources to actually figuring out first the security of machine learning before we go into the space? And also there was mentioned, for example, credit scoring, and this is the same problem. Like you can solve data and you can solve moving credit scores to blockchain, but you cannot actually solve how to enforce the result, how to force people to give you money because they can just scale. Like why credit scores work in real world, because then government can come up to you and then lock you up if you don't give money. So I feel like we're not actually looking into what are the real problems, but we're more looking into what cryptography, fun things we can do with cryptography. So I wonder what's your take on that?
Yeah, can you say, I was a little bit lost when you said why the score does not work on the chain?
Yeah, so basically I'm also very much interested in this topic. My idea was credit scoring seems very fun, but the very clear problem is that it's not just about moving the credit score, but actually enforcing that people give you money back. So if you have no enforcement mechanism, then people will not give you money.
Maybe I can answer on the credit score. Like the way I envision it, I mean, today we already have a way to enforce it on chain, right? You just tell people put like 150% collateral. The credit score is more like, well, okay, if the answer is under collateralized, good question. But I do think just like in the real world, when you have under collateralized and you have defaults and you have like insurances and you do have mechanisms that on average are like, EV positive. And if someone doesn't repay, then the next time they're going to ask a loan, again, you can privately compute their new credit score, and clearly they would need to put more collateral. So on average, I think we can build a system that is both transparent, like, there's no like too much leverage, too much like bad stuff. Again, not an economist, so take it with a grain of salt, but can still be, much more sustainable than we have today, plus giving people that work hard enough to build their credit scores to actually get like those benefits. But I do agree that we need to be very, very careful in this, and like maybe the safest margin to begin with is not below 100%. Maybe it's between 100 to 150. Maybe it's slightly like, playing around, up to like 90% or something like that. I mean, it's a work in progress, and I do agree with that.
Yeah, I definitely agree with. So if you always look at from the worst case, yeah, I think because we work in this domain, right? So we tend to always think about in the worst case scenario. Yes, I also do that. But you also want to make sure that the overall system exactly will reward the good behavior. Then give you the incentive, right? To say, oh, I should kind of, just like the credit score system doesn't really say, oh, if you got the bad score, you are the bad person, right? It's just like they tell you, hi, these are the ways you can like play along with the system and improve your score. And then more and more people will kind of not exactly be like manipulated in this way, but then they do this following the guideline and tend to kind of improve their score in general, right? And back to always the worst case scenario, I think at least our partners, we have been talking with a lot of them, right? And many of them are kind of in a stage to be mainnet launch like within next month or so. All of them understand the first step is actually the bottom line is to exclude not real, I would say, users or addresses, right? You have all these bots and everything. That's actually almost all the algorithm, whatever you call a machine learning, credit scoring system. The first step they do is basically filter out maybe 80% of the addresses, right? And then they only kind of keep the actual real user active addresses. So that kind of, there is with a high confidence, there is a real person behind that. So that's kind of basically address your question. Basically, yes, if the address is essentially free, why don't I just always create a random new address and basically default and leave the old address, right? So I think that's kind of, in the field, people are aware this is a possibility, unlike with government, you have a social security number that goes you for your lifetime, right? But all of this, instead of we kind of depend on a centralized government system, we can kind of offload the responsibility to the algorithm itself. Yeah.
So in Web3, I think it's sort of also like the difference between let's I guess look at it this way. Instead of you're right in the sense that the space that we exist in is fundamentally adversarial, right? And what that means is you can't really rely on people like behaving in like a good fashion. You don't really have like any meat space enforcement mechanism attached to any of this and stuff like that. So at the bare minimum, what you can sort of do is sort of like restrict the credit scoring to the person themselves. So for example, if I have a good history on Compound, that probably means that I have paid into the Compound protocol quite a bit in terms of like my insurance and fees and all of that stuff, right? So just that part sort of acts as a buffer against how much I can take out of the protocol, right? If that makes sense. So even if you reduce my collateral from like 150% to something like 120 or 110% based on my history of just paying into the Compound protocol, just that is good enough for a credit score, right?
Thanks so much. I'd just like to make discussion that it's not as clear as just, yes, use ML and we solve all the problems. But my actual question is more about ML security. And if any of you are familiar with the topic, there's a lot of adversarial attacks, there are backdoors of ML. And even if you essentially create a ZK proof that you run some model correctly, you never know if the model is actually working correctly and if it's done what you expect it to do. So I guess this is the elephant in the room of what we're talking.
Yeah, so in a sense, I think it's a bit of a silver lining that ZKML is quite expensive, because that kind of means we are almost forced to move away from all these like large impenetrable models and like go back to basics in terms of linear regression or something like that, right? So in a way, that means that our ML, like in the Web3 space at least, is like poised to be a lot more transparent, because it's like way simpler compared to what exists in the real world, right?
Ooh, we got to finish. We're out of time. I want to thank the panelists. Thank you for joining us.
Thank you.
Thanks.
Thank you.